Find the volume of the solid obtained when the region R is rotated completely about the x-axis. So first of all, we need the x-intercept. The x-intercept is the point where the y value is 0. It's going to be something comma 0. So the y is, this is the function, so this is the y. We are solving this equals 0. We have two possibilities, root x equals 0, cos x equals 0. Root x equals 0 means x equals 0. This is rejected because obviously this is not 0. From cos x equals 0, we have x equals pi over 2, which makes sense. So this is pi over 2. So the volume is pi integral from 0 to pi over 2 y squared dx. This is just like pi r squared, but it's y squared dx. Okay, so that's the volume formula, and the y is, again, this is the function, so this is what we need to integrate. Okay, so this is y. If we're using y squared, we're gonna have to square this, so it is x cos squared. Okay, that's y squared. So since we are integrating a multiplication here, we gotta use the integration by parts formula. So this is called the integration by parts formula. If we simplify it, so cancel out. In short, this is the integral u dv. So we are doing integral u dv, and it is equal to uv minus integral v du. uv minus integral v du. That's the formula. So first we need to identify the u and the dv. So whenever we have this kind of combination, a polynomial and a trigonometric, we always set the u to be the polynomial. So the u is x, which means du dx, the derivative of u with respect to x, the derivative of x with respect to x is 1. So du dx is 1, multiply both sides by dx, du equals dx. So if this is u, this must be dv. So dv is cos squared x dx. Now we integrate both sides. The integral of nothing dv, that's like the integral of 1 dv actually. The integral of 1 dx is x, so the integral of 1 dv is v. Now for the integral of cos squared, we're gonna need to use this formula here. So we're gonna have to rearrange using cos 2a equals 2 cos squared a minus 1. If we rearrange, we're gonna get cos squared a equals 1 plus cos 2a divided by 2. So using this, we combine, we solve for cos squared a. Cos squared a is equal to 1 plus cos 2a divided by 2, or 1 over 2 plus 1 over 2 cos 2a. Right, that's what we use here. Now we integrate, 1/2 becomes 1/2 x, and the integral of cos is sine using this formula. And we divide by 2 here because the angle we are dealing with is not just x but 2x, so we have to divide by 2 because that's the derivative of the angle. Okay, if this is 10x, we divide by 10. If this is 2x, we divide by 2. So that's the v. We have u, du, and the v. We have everything we need. So now we apply the formula u, v, v, du. We replace everything here, and now we simplify. So this is just the same, and from here we need to integrate this guy one more time. The integral of 1/2 x is 1/4 x squared using the usual integration rule, and the integral of sine is minus cos using this MF19 formula. So we have minus cos, but again divided by 2 because of the chain rule, because of the derivative of 2x. So now we simplify. So 1/2 x times x, that's 1/4 x. Actually 1/4 x squared, this is 1/2 x squared minus 1/4 x squared, so we have 1/4 x squared, and here we have x times 1/4 sine 2x. This is what we get, and we have a minus times minus, so plus, and this is 1/8, so plus 1/8 cos 2x. Now we plug in pi over 2 and 0 and subtract. So if we plug in pi over 2, we're gonna get pi squared over 4. So in the end, pi squared over 16. and here we have pi over 8 sine. This is actually sine pi, and if we use a calculator, sine pi is 0, so actually this is 0. And this is cos pi. Cos pi is -1, so we have -1/8 from here. And remember, there's a minus times this is just 0, this is just 0, this is 1, so -1/8 from here. Okay, so we have, from here we get this, and this is the 0. From here we get this, and from here there's a minus, we get this, not everything else 0. So we simplify, this is -1/4, and we still multiply by pi, so -1/4 pi, we multiply by pi, -1/16 pi cubed. Okay, so that's the final answer. All right, I'll see you